Okay, welcome to the second tutorial on using SuperSlicer, and in this tutorial we're going to proceed to load the Achilles tendon sequence of images and do a quick segmentation of the fibula. And in this tutorial I'll show you some more details about how SuperSlicer works and how we can speed up the process, and also how we can a couple of other programs that can be really useful and exciting. So let's get started. Let's see. The first thing we have to do is move to the directory where the images are stored. And I have unzipped the Achilles tendon images right onto my desktop. So here's the directory. So we move to that directory. Okay. And there we are. If I type ls, you can see the files in the directory. And so now we type SuperSlicer. And it's very convenient to run SuperSlicer in the directory where the images are stored, because it helps to keep the paths consistent. So now we just hit File, Load Images, and they should appear right there. And double click on the first image, and then we double click on the last image. Okay, and you can see the images are loading. All right. Now the first thing we want to do is just take a look at the images. So we scan through and we see, okay, here's the lower leg images, and you can see structures like the Achilles tendon, the fibula, and the tibia, which appear black in these type 2 MRI images. Okay, so now that we've loaded the images, well, the first thing that we need to do is we have to be able to input our scale factors. And in order to do that, it's usually typical that an MRI image or CT images have a scale bar, and that's what you see here in green. So what we're going to do is use this scale bar to determine our millimeter to pixel ratios. And in order to do that, we have to jump outside of SuperSlicer for a minute, and I'll type figure to open a new figure window, and I'll load in an image from the sequence. So let's see, we will load in Achilles, say IM show the 10th image. All right, and so the 10th image is now in a separate figure window, and as you can see, hopefully you can see, there is a scale bar on the side. All right, so we can use this scale bar and the command impixelinfo. All right, back to the figure window. And as you can see, we now have information about in the lower left corner about what pixel the cursor is on. So let's just say position the cursor to the end of the bar and read the number, which is 202, and then we'll position it at the beginning of the bar and read the number, which is 312, we'll say. So now we can jump out of here and type 312 minus 202, and that tells us there's 110 pixels in this 3 centimeter scale bar. So now we can easily determine our scale factor. Let's type 30 millimeters divided by 110. And there's our answer, 0.2727 millimeters per pixel. Now, what about the z-axis? Well, most CT images have this information right on the image, MRI or CT. And as you can see, it's right here. It's called THK, and this tells us that the Z thickness of the slices is 4 millimeters. So now we can close this window, and we have all the information we need to set our scale factors. There we go. And we can enter that in here, 0.2727, and typically the pixels are square, so we just enter in the same number here, 727, and our Z factor, which is 4. Okay, so now we've done that, and our reconstructions will now be accurate in terms of the XYZ ratios. Okay, so we're interested in segmenting out this fibula, so the first thing we'll do is we'll reduce the contour threshold in order to see approximately a good threshold for this fibula. And let's move back to the beginning. So approximately the first image that we can segment is this one, which is image 3. So we'll start at image 3 and we'll set a contour. But before I do that, I'm going to zoom in. It makes it a lot easier. So I zoom into this region. Now we can see it more clearly. Make sure you turn off the zoom button, otherwise things will go crazy. And that's what that red warning is all about. Now we can set the contour threshold a little bit better. I think that's about good. And we'll apply a keyframe. And now we'll move through the images and inspect. Okay, and even at this point I can see that we're over thresholding right now. So we need to reduce that threshold value because we really only want to capture that dark region. Right, so that's about right. And we'll add a keyframe. And we continue moving through the images. This looks good, it looks good. And there's a spot right there where it's not, where we're capturing a little more than we want, but we'll just leave that go for this tutorial. And finally, that's about the end. This is the end of the fibula. So on image 27, we want to stop segmenting. So we'll enter that in as the stop frame. 27. Okay. So now we go back to the beginning. We have our threshold set reasonably well. We're starting at frame 3, or slice 3. And we want to capture the fibula, but not just the outer contour of the fibula. We want to also capture the inner contour. So this is a hole, and so we just select Include Holes. And now we're ready to super slice. And you'll see that it's kind of slow. All right, wait for it. And there we go. So the SuperSlicer program is now going to move through the sequence of images, selecting the adjacent contours. And as you can see, it's relatively slow because it's operating on the whole image. And we're going to see how to fix that in a few minutes. All right, and I'm actually going to stop the video here for a second until we're at the end. Okay, that's it. We've sliced all the segments. Now we can take a quick look at the contours that we segmented. It looks reasonably good. All right. So we've been able to segment quite a long section of the fibula. And as you can see down towards slice 26 and 27, we're starting to lose fidelity. But for this demonstration, this is fine. We might have been able to tweak it to improve it a little bit, but you can experiment. So I'll close this window now. And I'm going to hit the reset button. And now I'm going to show you how we can speed up things and maybe we can make the surfaces a little bit smoother. Before I do that, I'm going to save the project so we have a point where we can go back to if something goes wrong. So save project. I'm going to call this test fibula and just hit save. I could type it in, but I already have one saved, but we'll just overwrite it. Okay, so now the project is saved. We're safe. Everything is saved. Now, the first thing I want to do is I want to speed up this process. I want to crop to the region that I'm going to be segmenting. So let's move to approximately image somewhere in the middle, maybe image 15. And I'm going to crop to this local region. So we can go Edit, Crop Images, select this region, double-click inside, and now we're cropped. Okay, so let's go back to the beginning. Slice. Just scan through quickly to make sure that we haven't cropped it too tightly. But no, that looks really good. And we're ready to go ahead and segment again. But before we do that, I'm going to show you one filter. It's called the median filter. And when I apply this filter, what you're going to see is that the image gets smoothed. And it's not a blurring, it looks blurrier. It's not really a blurring function though. What it is an averaging filter. And it helps to knock out some of that image artifact noise from the MRI or CT. So let's set it at 7. 7 looks like a reasonable number. Our contours are now nice and smooth, and we lose some fidelity of the actual surface, but we gain a more consistent surface, and that looks great. Okay. Often when you're generating these models, you don't want to capture every little detail of the surface. What you want is a nice smooth model. All right, so let's go back to the beginning. It looks like the contour thresholds are good. And what you're going to see now, I'm going to do the SuperSlicer, and you're going to see how much faster it is when you've cropped the image.